Back with day 86 here. In today's video, just as a heads up, I'm going to do a video today and I'm going to do a video tomorrow. So you're going to have two videos before you come back to class on Wednesday. Again, we're just making sure we get everything taken care of so we can get as many review days as possible before the AP exam. Today we're looking at revolving a region around a horizontal axis. Now we're used to that with the x-axis, right, which is a horizontal axis, but now we're going to do it around different horizontal lines. Okay, and basically what we need to do, it's going to work just like revolving. It's going to work just like the washer method. Okay, the difference here is the big R and little r are going to be just take a little bit more thought to figure out. Okay, so let me just sketch. I'm not going to do this at all with any real functions here. I'm simply going to use functions f and g. So we're just going to come up with the equations. These are almost always, you either just have to write the integral that's going to solve it, or it's on the calculator section, so you type it in, to your calculator. The hard part here is conceptually, how do we set them up? So take a look at this. Okay, so we have two functions here. We have the blue function is f of x. The green function here is g of x. So there is our bounded region right here. I'll shade it in black. So what we're going to do is we're going to take that region, right? Today we looked at revolving that region around the x-axis, but today we're going to revolve it around the line y equals -4. So here's -4. So we're going to revolve it around the horizontal line y equals -4. So when we revolve this thing, right, we're going to get a big, huge washer coming out here. Okay, so when we think about this thing, what we have here, again, is a big radius and a little radius. Okay, and then the volume here is still going to be pi times the integral from a to b of big radius squared minus little radius squared. But now the radius isn't simply just the function alone, right? Since the axis we're revolving around is this line y equals -4 down here, the big radius does tie to the top function, f of x, but it's not just f of x. Okay? F of x is the distance from the function to the x-axis. So this distance right here is a distance f of x. But that is not the radius, right? The radius also includes this distance. Okay, and what is that distance there? Well, since this is -4, the distance it is from 0 is 4. So big radius then is f of x plus 4. Okay, it's supposed to be a 4. I'm out of room up there. The little radius then, again, is this whole distance. This whole distance is the little radius. This part right here is g of x. This part right here, once again, is 4. So the whole length of this line, segment addition postulate from geometry, is g of x plus 4. Okay, therefore, our equation for our volume here, right? I need to find this intersection. We're going to call that A. We're going to find this intersection and call that B. So our volume here is pi integral a to b. Now it's big R squared minus little r squared. But remember, we have our big R and our little r written up here. So we say f of x plus 4 quantity squared minus little r, which is quantity g of x plus 4. G of x plus 4 squared dx. So that right there, unfortunately I ran out of room. I'm just going to write that a little bit cleaner. All right, so it'll be parenthesis f of x plus 4 squared minus g of x plus 4, that quantity squared dx. That will be our integral that sets up to give us the volume of that. Right, so it's really not that much harder, I don't think, than revolving around the x-axis. We just have to adjust our big R and our little r. Okay? So that's for a line below the function that we're revolving around, right? But what if we revolve it around a line that's above it? Okay? Well, we can still solve it. Let me show you that example here quick. And here's f of x. And here's g of x. This point is A, this point is B. Okay? Now we're going to revolve this thing around a horizontal line that's above the two functions. So let's just say 1, 2, 3, 4, 5, 6, 7. Let's revolve it around the line y equals 7. Okay? Well, when we do that, right, when we revolve it upwards, we're going to get a big washer, something like this. Maybe made that go too high. Hold on. So there's our big donut that we get, right? And what we have to do now, this is the one that takes, I think, just a little bit more brain power than the other one. Okay, here's big R, here's little r. Big R now is not tied to the top function anymore. Big radius is actually tied to the bottom function, g of x. So what we need to do is come up with an expression for that distance from the function g to the line of rotation, which is y equals 7. Now, how the heck do we do that? Well, we can't just add 7 here. It's not how it works. So here's what I want you to think about. I know that the distance from function to x-axis, this distance right here is a distance g, right? That's how we define it. The whole distance from here to here is 7. So I should end right here. That distance is 7, this distance is g. So what about this big radius then? Well, I have to use segment addition postulate, but I have to subtract. The whole thing is 7. This little piece down here is g. Big radius now is 7 minus g. So I have to take the whole number 7 and subtract away the little piece of g to get it. I'm going to do the same process for little radius here. This little radius, this distance right here. Again, this distance is 7. This distance is f of x. Therefore, this distance is 7 minus f. So little r is 7 minus f. So whenever we revolve a region above, right, we're going to have to do some subtraction here. We'll take the number and subtract away the function to get the remaining little piece. Okay? So again, not super crazy difficult here. But it does take a little bit more brain power to think about that. We have to subtract 7 minus g and 7 minus f. Okay? Now to write the integral, now this part is easy. So my final answer here is, our volume is pi integral a to b of big R squared. So that's 7 minus g minus little r squared, which is 7 minus f of x dx. Again, they rarely make you solve those without a calculator. If they did, we would have to do it, right? We can do it as long as the functions don't get too crazy. But usually you just have to set it up and then you're done, or you set it up and solve it, but you can use your calculator. The setup here is what is very important to learn today. Okay? So we'll see some examples of these types of questions on Wednesday in class, as well as examples that I'm going to show you on tomorrow's video. So we'll have 2 videos to watch for Wednesday's class. Talk to you guys later. 2 chains, bye.